rules to filter traffic and test. So we have to come up with some scenarios that are of interest that we may want to restrict. So let's see which ports we're listening to, services that others remotely may be interested in. So netstat.ntl shows us TCP listeners, for example, although you can write UDP rules, but TCP tends to be the easiest to test using Telnet, for example. So netstat.ntl shows that we're listening to perhaps too many ports. 2049, NFS, 514, because our syslog interface binds to TCP as well as UDP. 3306 MySQL. Postfix is listening on loopback. Doesn't appear to be listening on the routable interface, so this is not a concern. So we have to pick a port that's worth restricting. SSH is one of those ports. That's possibly a target port that we could pick on. So either SSH and or MySQL. So let's go with SSH initially. So supposing we wanted to restrict inbound traffic to SSH. This is an important port to restrict in your organization because SSH is powerful. It can be used to create pseudo VPNs to move traffic in and out and to circumvent your firewall policy. So users in your organization can set up, let's say, PuTTY on their Windows desktop or SSH if they're using Mac or Linux or any Unix flavor for that matter, and they can create outbound sessions that they can then attach to from home or remotely on the outside of your corporate network, entirely circumventing your firewall if you allow SSH outbound. So you have to be very careful with SSH because it can allow traffic into your network that you didn't intend or anticipate or expect or even allow. So one task for us could be to filter traffic inbound, let's say based on a particular host. So supposing we're pretending our Windows system located at 105 is the bad guy or the outsider, and we don't want that particular system to be able to source traffic to us on port 22. That's the input port that's of concern. So we'll use IP tables. And there are a number of ways in which you may add rules to a given chain. You can append, and it'll be added to the end of the list. You can input at a specific line, if you'd like. Let's say line number 3, for example. Since there are no rules defined, let's just go ahead and append to the input chain. Now, when specifying rules, you get to describe all the characteristics of the rules, such as source port, destination port, source IP, destination IP, the properties that are found in the TCP IP headers. So when we IP tables list, for example, we see no rules are defined in either of the chains, and we see the default policy of accept for each of the chains, which means input traffic to all ports, traffic to be routed, as well as output traffic that we source. Everything's permitted currently from the perspective of this filter table. So when writing a rule, we should indicate a target, protocol, optionally options that are found in the header of the protocol, source and destination addresses. And there are tags to indicate each of these. IP tables help will reveal them. But for example, to input a rule into the input chain that governs a particular source address, we can indicate a source address of, let's say, 192.168.75.105 in this case. You can optionally indicate, for example, a CIDR notation. Let's say the entire subnet is denied 22 access, or a specific host, which is implied by just specifying the IP address. Now, if SSH is bound to a specific IP, you can specify that using the D option, or you can omit it to mean any destination for which we're hosting. Now, the protocol option is important because you want to indicate that it's a TCP port in this particular case. You can also indicate a destination port of 22, for example, to be more specific. So the protocol's TCP, the destination port is 22. Otherwise, you would deny all TCP traffic from 105 to our local system. So to be more clear, to be more exact, to be more granular, the destination port or port range is always important. When writing IP tables rules, it's helpful if you indicate a target. Targets include, for example, but not limited to, drop, deny, and accept. drop will simply drop the traffic without returning a gratuitous message to the client that's attempting to pass the traffic. So this rule will be written to the input chain, barring no errors. It will match if the source IP in the IP header contains 105, if the protocol is TCP, if the destination port is 22, then it'll be dropped. So let's go ahead and copy this rule, and we'll paste this in, echo the exit status. So far so good. Now let's IP tables list again, and there is our first rule. Now because we have resolution for the IP address 105, it shows up as its host name as the source. The protocol will be TCP to any particular destination for which we're hosting port SSH or TCP22. That means when you netstat, for example, NTL grep 22, and you see that 22 is bound to all IP addresses here, no matter which IP we're listening to, which include 7523, 7522, 7521, no matter how that host tries to get us on port 22, IP tables will drop the traffic, coming only from that host, of course, and we can confirm by trying from other hosts. So that's our first rule. Now, to confirm that this is all working, and by the way, you can, just like you with other programs, you can, let's go ahead and just show you one other thing you could do if you want to drop the resolution. You can use the N option or long form numeric. So let's go ahead, this will be as a separate option, and it drops the resolution so that you can see the raw IP address. So to confirm that this traffic will be dropped, let's launch an RDesktop session to the Windows host, which we presume to be up, and we can always check with Nmap since we've covered it. So Nmap 75105 will tell us if it's up, and it indeed is according to Nmap. Nmap scans roughly over 1600 ports rather quickly, 5.77 seconds, and has determined that we should be able to connect on terminal services. So let's find a shell where we have invoked our desktop. This should take us full screen to that host. And there's the login. So we will connect as AD Linux CBT, which is the name of the domain, or Linux CBT at the FQDN. Either or will suffice. And momentarily we will have the opportunity to try to putty in to SSH. So here's a putty instance. If Telnet's available as a client, that makes it quicker. So let's try to Telnet to 192.168.75.21.22. That's not working. And of course, if we try with putty to connect to, let's load serve 221, try to open, that's going to bomb. But of course, if we try to connect elsewhere, let's close the server manager. So long as IP tables is not a factor, then it'll allow us to connect. For example, let's try to connect to the Debian host 101. And indeed we can connect. So that tells us IP tables is doing what is expected. And of course, if we try to connect to, let's say, other ports on the host 21, like 80 for example, Apache, which is running, indeed we're able to connect, and it returns the default. So 22 is now off limits. Now by default, IP tables will not log that correspondence. You can write an additional rule with a target of log to cause it to log the traffic for you. Now we can always circumvent this by puttying into a different host and then puttying back. So for example, we could connect to build 1, which is the Debian box, which allows SSH. So let's connect here. And then there's nothing to prevent us from connecting to 7521 from here. So now we have a session on. And then let's IP tables list, and you will see the lone rule, which doesn't impact us at this particular point. Again, IP tables with help reveals a number of options, and there are a number of sub-options, by the way, on a per protocol basis that will help you to figure out how to filter traffic. In particular, with many of the types like ICMP, for example, the various types have a lot of options that are worth exploring as sub-options. You can flush rules, for example. You can zero out the counters, for example, using the Z option, or flush using the F option. Flushing will wipe all of the rules, but of course it helps if you back things up before wiping out all of those rules. So, how do we back up this rule? Using IP table save. If we take a look at etc sysconfig IP tables star, notice there's an iptables.old file. That is the original config file from the installation. So if you back up, you could back up to this directory, to that name, and then restore using that name if you'd like. So for example, iptables save will dump, let's just get this, we missed the L, will dump to standard out the current configuration. So this is the current configuration. So and notice it also has the counters associated with it. So here are the input counters. So to back this up, you'll use output redirection and specify the file name, such as etc sysconfig iptables.old. And this will become the rule set. Echo the exit status, and let's LSL and note that it's been relative to our current time updated. Indeed. So now when we flush the input chain and then IP tables list, the rule has been wiped. And then if we try to connect again from the Win host, it will work this time to port 22. So let's change this to 22, and now we can connect. So it's working. And if we launch PuTTY in a separate window using a new session, for example, to Linux CBT Serve 2, it will connect. So that's working as expected. Let's open this session anyway, and to reinstate the rule, iptables restore, point it to the file which is located in etc sysconfig iptables.old. You don't have to name it iptables.old, by the way. So now let's iptables list again, and there's the rule. So now, what does that mean for the existing PuTTY session? It's dead. So no matter what we type, we can't interact with it. And if we try to launch a new session to it, either via the command line, this will die momentarily. It's actually frozen. But let's try to launch a new session, and it's going to bomb because the rule has been reinstated as expected. So this will not bring up an interface, an opportunity to connect, because we've reinstated the rule. So as mentioned, you can log this information by including a log target if you'd like. It's one of the supported targets, but that depends on your corporate policy, whether or not you need to log all failures of traffic. Let's just go ahead and tell this